So now that we understand how global warming occurs, we can now look at other aspects that can increase, for instance, greenhouse gases, or we can also look at the effects of global warming. And these are based on very complex models, right? But it comes from very simple cause-effect understandings that allows also to understand feedbacks on these cause-effect dynamics, right? So when we look at something that is called a stock or a reservoir, is the amount of something, let's go CO2 or energy, how this is changed or varies with different dynamics and activities and flows, all right? So how is this depleted or increased? This is what we call, what is called feedback loops. And we're going to understand this by understanding the connections between different dynamics that are going on in the Earth, right? So to start with, we're going to start to understanding that there are close connections between global temperature, atmospheric water vapor, and cloudiness. There are also connections in the extent of polar ice caps and levels of greenhouse gases in the atmosphere. When one of these is disturbed, such as by human activity, the others react through processes that amplify the original disturbance until a new, different climate equilibrium is reached. So let's look at this figure. This is a glacier in New Zealand, and then we can see what was before and after. These are beautiful pictures that you can find in the global climate of the website of the NASA, and when they can actually, they tend to show, they try to show the impacts of global warming by looking at pictures from previous years and current years, and how the landscapes have changed, right? So in this landscape, it's clear that we have different amount of ice cover in this region, right? Think about what would be the effect, the changes on the albedo by having this. We know that the albedo, it's different if we compare with ice as we compare with dark land, because it also varies with colors, right? Then we can also get to predict how much energy will be absorbed or will be radiated, right? So these things are the things that allow us to start making cause, effect, and then feedback loops, to creating these feedback loops to understand what will be the causes of this global warming in an overall, in a bigger picture. So the melting of polar ice is a concern because it will increase energy absorption, and water has a lower albedo than ice and enhance warming globally. These and other feedbacks and some tipping points at which sudden change occur are critical factors in climate change. Another important feedback is the CO2 release from warming and drying peat. Peat is soggy and is organic matter accumulated over thousands of years across the vast expanses of tundra, especially in the northern hemisphere, in Canada and Siberia, right? As this peat thaws and dries, it oxidizes and decays, releasing even more CO2 and methane. So then do you see now the connection? How these pieces are connected and will return a higher impact. In this case, we're looking at examples that amplify the impacts. We call it positive feedbacks. But there could be some other negative feedback loops. So something that damper, for instance, the CO2 that is being released. For instance, increased ocean evaporation could intensify snowfall at high latitudes, restoring some of the high albedo snow surface. So these are the figures that we were talking about. So we're talking about, on the left side, the feedbacks in glacial cycles. And then on the second figure, we're talking about feedbacks in human-induced climate change due to this the intromission of the greenhouse gas emissions from human activities, and how this will change these dynamics, right? In this case, in these figures, we can actually add whether an increase on changes on greenhouse gas will increase the change in temperature or will decrease, and we will have negative and positive signs that will give us a better indication on what will be the overall impact. Okay. So where can we look at global climate change impacts? Well, we can look at effects everywhere. So we can look at ocean, sea rise increase, temperature, how this will affect, for instance, the amount of CO2 that is being stored in the oceans, or what will be, or how this will increase activity of the rainforest, for instance. So there are a lot of things going on, and scientists are looking at explanations and looking at these feedback loops to understand what will be the main effects. What we're going to do in this exercise, we're going to have an example of a global feedback loop, and I'm going to tell you this story, and then we're going to try to explain this story in a way of how cause in a way of cause effect drawing. Okay. So it is hypothesized that increasing CO2 emissions into our atmosphere will cause the Earth's global temperature to rise. This in turn will reduce the ability of the Earth's oceans to hold gaseous CO2, thereby causing the oceans to release additional CO2 into the atmosphere. This additional increase in atmospheric CO2 will lead again to global to warming, right? To an increase in temperature, which then lead to even more CO2 released from the oceans, and so on. Okay, how can we describe this? We have a very simple way to describe this. That is, release of an increase in global temperature will allow the more release of CO2 from the ocean. And then by releasing more CO2 from the ocean to the atmosphere, this will again increase the global temperature. The main rule for this for describing into feedback loops processes is that they will go back to having an effect to the thing that we were looking at from the beginning. That's the general rule. So it has to have a direction, right? Pointing out that at the same time it will also have an effect on the point that we were looking at from the beginning. All right. So in this case, this feedback will amplify the effect, which means that it will continuously increase CO2 as we are looking at. Okay. We can also have signs. We can have positive, because an increase in release of ocean CO2 will increase the ocean the CO2 in the atmosphere, and an increase in the CO2 in the atmosphere will increase the global temperature, and again and again and again. Okay, so this could lead to runaway accumulation of CO2 in the atmosphere, right? So is it? Well, let's look at other scenarios that can occur. Increases in global temperature will lead to more evaporation of the ocean waters, thereby leading to an increase in cloud cover over the Earth's surface. This increased cloud cover will increase the Earth's reflectivity, so the albedo. This increase in albedo will reflect more sunlight away from the Earth and allow the Earth to cool off. So that means that we can actually have additional components in this feedback loop that may allow probably to dampen the effect. Okay, well, we can look at different scenarios and we can look at different feedbacks, and this has been described by many scientists. And so simulation of these processes on a global scale over large time scales still remains a very challenging area of scientific and engineering research. These feedback mechanisms provide an example as to why forecasting the weather is challenging. So we have here another example, and the example is about what happens with only looking at the evaporation rate. So warming climate leads to an increased evaporation rate, more water vapor in the atmosphere. Water vapor is a greenhouse gas, so causes even more warming. So this is another example, and this is another, again, a positive feedback loop, all right? That you can actually make it in the way that we were describing before, with the arrows that tell us the cause effect, okay? And these are other examples of feedback, positive feedback that increase warming. So look at these examples and look at if you understand these examples, and see if also you can put positive or negative signs on these ones, so you can see if you are able to understand and if you are able to make your own feedback loops. So thanks to this, based on rough mathematical models, but also on these feedback loops, we have now more accuracy on about global warming scenarios. So global warming scenarios based on models are also allowing us to predict what will happen if we take one direction on the way that we live and act here on the earth, or the way that we have activities. It can allow us also to be more prepared to what's going on in the future. So this is, for instance, global surface warming, and also we have different scenarios here and different models, and there is a big variability among models. And now these scenarios can be simulated based on a simple model that we described before, and then going into more fundamentals with more information that can provide us better estimates.